Graph of the inverse sine function. Let's try to graph y equals sine inverse x on our graphing calculator using this given window. Let's see, I am in radian mode. I'll go to the y equals area, type in sine inverse of x, and then the window requested was -3 to 3, counting by ones on both the x-axis and the y-axis. So we'll fix those numbers. And then let's hit graph. And here's what we see, kind of an unusual picture. It's a very small picture. In fact, unlike most graphs we draw, it doesn't even continue on forever in both directions. It has a stopping point here at the top and a stopping point here at the bottom. Now, if you think about it for a minute, this should make good sense to you, because when we created the inverse sine function, we had to be very restrictive. The inverse sine function can only take in ratios between -1 and 1. In fact, I think you can see that here. Here's -1, here's 1. It makes sense that there's no portion of the graph past that in either direction. And then the inverse sine function can only send out angles that are between -pi/2 and pi/2. Now we'd like to figure out what are the coordinates of those endpoints. Well, it must have something to do with those restricted values. Let's use the trace function and send in 1 and see what we get. So I'll hit trace, type x equals 1, and what I end up with is this 1.57. Now we've seen that before. I don't know if you recognize it. That is exactly half of pi. It's pi/2. Doesn't that make sense? On the inverse sine graph, here's the ratios, here's the angles. Well, the highest angle that inverse sine knows about is pi/2. So of course this must be the point 1 comma pi/2. If I repeat the process and type -1 in, of course it's just going to take me to -1 comma pi/2. So now that we have that information, we realize that it probably would have made sense to, yes, count by ones on the x-axis, but on the y-axis we probably should have just counted by pi/2. My two endpoints, 1 comma pi/2 and -1 comma pi/2, and then the graph looked something like this. That's the entire graph of the inverse sine function. Thanks for watching.